Welcome to this lesson on convection, one of the three fundamental modes of heat transfer in thermodynamics. Convection is the process by which heat energy moves through fluids, that is, liquids and gases, by the actual movement of the fluid itself. Unlike conduction, where heat transfers through direct contact, or radiation, where heat travels through electromagnetic waves, convection relies on the bulk motion of fluid particles carrying thermal energy from one place to another. Convection is defined as heat transfer through the bulk movement of fluid particles carrying thermal energy from one location to another. The key aspect here is that it requires a fluid medium, which can be either a liquid like water or a gas like air. In convection, mass movement is involved, meaning the fluid particles themselves physically move and carry energy with them. This is fundamentally different from conduction, where only energy transfers through a material, not the material itself. Let's understand how convection works through a four-step mechanism. First, when a fluid is heated at the bottom, it becomes less dense because the molecules spread apart. Second, this hot, less dense fluid rises upward due to buoyancy forces, similar to how a hot air balloon floats. Third, as the hot fluid rises, cooler and denser fluid from above descends downward to replace it. Fourth, this creates a continuous circulation pattern that effectively transfers heat throughout the fluid. This cycle repeats continuously as long as there is a temperature difference. Natural convection, also called free convection, occurs when fluid motion is driven purely by buoyancy forces caused by density differences due to temperature variations. No external device is needed to move the fluid. Common examples include sea breezes, where warm air over land rises and cool air from the sea moves in to replace it. Hot air balloons rise because the heated air inside is less dense than the surrounding cooler air. In room heating, warm air from a radiator naturally rises to the ceiling while cooler air descends to be heated. Forced convection occurs when fluid motion is driven by external means such as pumps, fans, or wind, rather than by natural buoyancy alone. This method creates much higher heat transfer rates compared to natural convection. A car radiator uses a pump to circulate coolant through the engine, rapidly removing heat. Cooling fans blow air over hot surfaces to speed up cooling. The wind chill effect is forced convection, where wind forces air movement over your skin, making you feel colder than the actual air temperature. Convection plays a vital role in many natural phenomena. Ocean currents form when warm water at the equator rises and moves toward the poles, while cold water from the poles sinks and moves toward the equator, creating global circulation patterns. Atmospheric circulation occurs when warm air rises, creating low-pressure areas, and cool air descends, creating weather patterns and winds. Deep within Earth, mantle convection drives plate tectonics as hot molten rock circulates beneath the crust. Thunderstorms form when rapidly rising warm, moist air creates powerful convective clouds. Convection is present in many everyday situations. When boiling water, hot water at the bottom of the pot rises while cooler water descends, creating a rolling motion. Home heating systems use radiators that warm the air, which then circulates naturally through rooms, keeping them comfortable. Refrigerators work by having cold air sink to the bottom while warm air rises to the cooling coils at the top. Air conditioners use fans to force air over cold coils, utilizing forced convection for rapid cooling of indoor spaces. The rate of heat transfer by convection is given by the equation Q equals H times A times delta T here. H is the convection heat transfer coefficient, which depends on the fluid's properties and how fast it's moving. A is the surface area through which heat is being transferred. Larger areas allow more heat transfer. Delta T is the temperature difference between the surface and the fluid. A greater difference drives faster heat transfer. Additionally, higher fluid velocity enhances convection by bringing fresh, cooler fluid into contact with the hot surface more quickly. Let's summarize the key points about convection. First, convection requires a fluid medium, either liquid or gas, for bulk motion to occur. Second, it is driven either by density differences caused by temperature variations in natural convection or by external forces like fans and pumps in forced convection. Third, convection is more efficient than conduction for rapid heat transfer because it moves large amounts of fluid carrying thermal energy. Finally, convection is essential in weather patterns, ocean currents, and everyday technology like heating and cooling systems. Understanding convection helps us grasp how thermal energy moves in fluids all around us.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.